Hi, in this video, we're going to learn how to solve equations, simple equations. But first, we will learn algebraic expressions. So we define algebraic expression. An algebraic expression consists of numbers, variables, operation, and or grouping symbols such as parentheses and brackets. So, uh, as defined, algebraic expression composed of numbers or variables with operation symbols and or grouping symbols like parentheses or brackets. Example, we have this number 1, x plus 5. X plus 5 is considered a algebraic expression because it consists of numbers. So we have 5, a symbol or a variable, and an operation. So this one is by definition an algebraic expression. This one is also algebraic expression. We have a variable, a number, and an operation. This one is n divided by 2. So we have a variable, a number, and an operation. This one is also an algebraic expression because we have a number, a variable. We have operations here. Operations present here are minus and subtraction and multiplication. So we have two. This one is another example of algebraic expression. Consists of numbers, we have variable, of course we have operation, that's addition and multiplication. Here we have number 6, 3 times the quantity of x plus 9. So we have operations, multiplication, okay, 3 is multiplied to this quantity, and addition. So we have, of course, a number, we have numbers here and a variable. So by definition, this one is an algebraic expression. 2x, for example, is another 2x is another example of algebraic expression. Okay, so because this one consists of we have variable and a number, and we have an operation here which is multiplication. So still 2x is considered as algebraic expression. Even let's say 3 plus 5. 3 plus 5 is an expression because it consists of numbers. Okay, it does not mean that we have to have a variable or a grouping symbol. So in this definition, it is clear that uh, it uh, it can also be in numbers alone, like this 3 and 5. And of course, we have an operation which is plus, so meaning 3 plus 5 is considered as an algebraic expression. Even a constant, let's say 5 is considered an algebraic expression because this one 5 alone is having only a number, having no symbols, operations, or variables, or grouping symbols. So by definition, if you look at the definition of algebraic expression, 5 can also be considered as algebraic expression, and so on and so forth. So there are infinitely many examples of algebraic expression. So let's go to equation. We will define equation. An equation in one variable is an equation in one variable. So we will consider equation in one variable only to make it simple. Okay, is a statement in which two expressions are equal. So meaning equation is a statement in which two expressions are equal. And of course, equation is always involve this symbol, which is the equal sign, which is called the equal sign, that separates the parts known as the left member and the right member of an equation. So for example, we have number 1, the quantity of x plus 1 times the quantity of x minus 1 equals x squared minus 1. So as you can see, this one is an example of an equation. We have the right, the left and the right members of our equation. So this one is an equation that expresses the equality of these two expressions. Okay, so it expresses the equality of two expressions, this one and this one. Okay, so which means to say that this expression is equal to this expression. Okay, later we will find that value of that unknown or variable that will make our equation true, or meaning the left will be equal to what number or numbers that we are going to substitute, so that the left will be equal to right. Okay, but right now equation by definition is a statement in which two expressions are equal. So meaning this x plus 1 times the quantity of x minus 1 is equal to the quantity x squared minus 1. Okay, another example of an equation is, as you can see, equation is always involve the symbol equals. Okay, so meaning this equation now is actually not an expression. Okay, because equation involves a symbol which is denoted by this, as you can see. Number 2, we have quantity of 2 times the quantity of x minus 1 divided by x minus 1 is equal to 2. This is another example of equation, of an equation. This is an example of an equation indicating that the left side is equal to the right side. Okay, so again, number 2 is an example of an equation because it involves a symbol called equals. This is the equal sign. Later we will solve equations, which means that we're going to find the particular value of that unknown or variable that will make our statement true. Anyway, before we do that, let us learn what is the so-called types of equation according to the permissibility of a variable. So we have two types of equation according to the permissibility. First, we have the so-called identity equation, and the second one is the conditional equation. So what is this called? What is this so-called identity equation? This is a type of equation that is always true for all permissible values of the variable. So let's say, for example, so what is this permissible values of the variable? So these are the values that we can substitute in our values of x or any variable that will make our expressions defined. Okay, so example for number 1, what are those values of x that we can substitute, okay, so that our left and right sides will not be undefined? Okay, kano sa ito ma-undefined? If the denominator is 0 and you have a numerator that is non-zero, let's say 2. So this one is undefined. So we will avoid this kind of expression. Anyway, what are those values of x that we can substitute so that the left and the right sides, okay, the left and the right sides will not be undefined. So as you can see, the values of x that we can substitute is any number, okay, or all real numbers, right? So as you can see, we can substitute any real numbers or any numbers. Okay. Now the question is, when you substitute any real numbers, which are the permissible values of our x in number 1, are all permissible values, which are real numbers, will make our equation true. In other words, the left side will be equal to the right side if you're going to substitute any real numbers. Yes. Any real numbers, if you're going to substitute, let's say 0, this will make our equation true. So if you substitute here, for instance, 0 plus 1, and you have 0 minus 1, is it equal to 0 squared minus 1? So in this case, we have 1 times negative 1, which is negative 1. Here we have our answer here is negative 1. So negative 1 is equal to negative 1. If you're going to substitute any real numbers here, our left side will always be equal to the right side. So meaning all our permissible values, which are real numbers, will always make our equation true. So which means to say that number 1 is classified as identity equation. Another example of identity equation is this number 2. So okay, for number 2, we have this one. 2 times the quantity of x minus 1 over x minus 1 is equal to 2. Okay, now examine closely. What are the permissible values of x? So what are those values of x that we can substitute in our expression, or in our equation in general, so that our expression on the left side, in this case, will be defined, or equivalently will not be undefined. Okay, so what are those values that we can substitute for x? So all real numbers except 1. So we can substitute any real number. So all real numbers, or all numbers except 1. So because if you're going to substitute 1 here, 1, so the denominator will be equal to 0. So we don't want that to happen. When our denominator will be 0, and of course our numerator in this case will become this will become 0. So we don't want this to happen. This one is actually 0 over 0 is indeterminate. We don't want to be in that situation. Okay, indeterminate, or we don't also want to be in the position that our expression will become undefined. Okay, either of the two. We don't want that to happen. Okay, so what are those values of x that we can only substitute in our expression to the right or to the left? All real numbers except 1. Okay, so the permissible values are all real numbers except 1. Okay, now, are all those permissible values will make our equation number 2 true? Of course, we are not allowed to substitute 1. So let's try now if those permissible values will make our equation true. Yes, because intuitively, you can see that our expression, yes, will become equal. Our expressions in the left and right will be equal when we substitute all real numbers except 1. So let's say 2. So this becomes 2 times 2 minus 1 over 1 equal to 2. So this becomes 1 times 2. 2 over 1 is 2 over 1 is 2. That will be equal to the right side. If you substitute any numbers here except for 1, the left and the right will always be equal. And therefore, this one is, by definition, it is classified as an identity equation. Now, how about for number 2? Number 2 is a conditional equation. A conditional equation is a type of equation that is true, okay? Equation that is true for some permissible values of the variable and false for other permissible values. So it's not like the identity equation. For identity equation, it is always true for all permissible values. For conditional equation, it is not true for some permissible values of the variable. Example of a conditional equation is this: x minus 2 equals 5. Okay, x minus 2 equals 5 is a conditional equation. Why? Okay, examine first the permissible values of x. So you can substitute any values of x. Okay? Because if you substitute any values of x, the left side will always be defined, right? So it will never be undefined or indeterminate, okay? But the question is, are those all permissible values will make our statement or equation true? No, because if you substitute 4, which is a permissible value of x, okay? Remember, our permissible values of x are those real numbers, any real numbers. But not all those real numbers, which are permissible values of x, can make our equation true, right? Example, if you substitute 4, this becomes 4 minus 2, right? 4 minus 2, which becomes 2, which is not equal to 5, right? So not all permissible values will make our equation true. Okay. So the only number that is a permissible value of x, and at the same time will make our equation true, is the number 7. Okay, because 7 will make this equation true. Okay, it's obvious. 7 minus 2, of course, that is 5, which is equal to the left side, which is 5. So the only number that will make this statement or this equation true is number 7. Not all real numbers. So it is true for some permissible values, in this case 7, and false for other permissible values. So in this case, all those real numbers except 7. So which means that x minus 2 equals 5 is a conditional equation. Okay? So dili tanan permissible values at x will make our equation true. So most of the time we will deal with conditional equation, and then we will develop some techniques in order to solve our conditional equations. So when I say equation in this discussion, we mean conditional equation, unless otherwise stated. Okay, so sometimes we will encounter identity equation, but most of the time we will deal with conditional equation. So in the next part of this video, we will develop a technique and how we're going to solve conditional equations. So that would be all for this video. Thank you very much and have a nice day.